Thanks, Brad, and hello everyone. My name is Alex Bozmoski, but everybody calls me Boz. I'm the Chief Engineer for the Pan America project. With the vision of the Pan America defined, a mission of what we wanted to achieve, and a bold design interpretation of the adventure touring segment, here's what went into engineering the Pan America experience. Every team member that joined Pan America was onboarded to deliver function first, creative solutions, and drive strong integration between the teams. Every single part and feature was scrutinized by Graham throughout the project. Nearly 1 million miles of powertrain development were completed. Vehicle development was split 50% off-road and 50% pavement. Extreme duty cycle testing of components and shaker rigs simulated the worst riding environments. We created our own off-road development course modeled to automotive standards, and prototype suspension wheels and components were utilized in building the long way up live-wire motorcycles. To accomplish the mission, we knew the engine would be key, delivering the performance characteristics, low weight, and low center of gravity, plus the multidimensional rider comfort that adventure touring customers demand. We designed an all-new powertrain from the screws up for the task at hand, and purposefully suited for the adventures ahead. The Pan America 1250 and the Pan America 1250 Special models are all powered by the all-new Revolution Max 1250 engine, a liquid-cooled V-twin design that offers flexibility, engaging performance with a broad power band that provides impressive low RPM grunt through exhilarating high RPM power. No matter what you're doing, the throttle will deliver on command. I have had the honor of working on legendary powertrain development programs from Evolution to Twin Cam to Chief Engineer of the Milwaukee 8, and I'm thrilled to introduce the next legendary V-twin powertrain from Harley-Davidson. The Revolution Max 1250 engine has been tuned specifically to deliver desirable power characteristics for the Pan America 1250 and Pan America 1250 Special models. We felt it was critical to have smooth, low-end torque delivery and low-speed throttle control applicable to off-road riding. A focus on performance, weight reduction, and weight distribution drove both vehicle and engine architecture, material choices, and aggressive component design optimization. The engine is integrated into the vehicle as a central member of the chassis, designed both to minimize overall weight while improving vehicle stiffness. The use of lightweight materials helps achieve a desirable power-to-weight ratio. Harley-Davidson focused on weight reduction at every phase of Pan America 1250 development, starting with the powertrain. Reducing the weight of the powertrain contributes to lower motorcycle weight, which enhances motorcycle performance, efficiency, acceleration, handling, and braking. The use of finite element analysis and advanced CAE design optimization techniques through many iteration loops of the engine design process minimized material mass in castings, forgings, and molded components. Single-piece aluminum cylinders with nickel silicon carbide surface galvanic coating are lightweight, low friction, and extremely durable. Sprocket covers, cam covers, chain covers, and primary covers are lightweight magnesium. The architectural decisions, advanced technology integration, and discipline to weight reduction and distribution were painstakingly balanced to provide confidence and excitement for the rider. Why a V-twin? Not only is it core to Harley-Davidson's identity, but it unlocks a raft of benefits for riders in the adventure touring space. The V-twin design provides a narrow powertrain profile that centralizes mass to enhance balance and handling while providing ample foot and leg room clearance for the rider. The Revolution Max 1250 powertrain is a structural component of the motorcycle chassis. The engine serves two functions, providing power and acting as a structural element of the chassis. Double overhead camshafts and variable valve timing provide unlimited tuning capability. This is a fully balanced powertrain. Internal balancers cancel most of the engine vibration to enhance rider comfort and improve vehicle durability. The balancers are tuned to retain just enough vibration to make the motorcycle feel alive. The Revolution Max is an all-new design from Harley-Davidson, not a derivative of previous liquid-cooled powertrains. Heat is an enemy of both durability and rider comfort. Liquid cooling maintains a stable and controlled engine and oil temperature for consistent performance in changing environmental and riding situations. And liquid cooling is a key aspect in the Revolution Max engineering effort. Significant energy went into controlling weight and providing Harley-Davidson's original aesthetics. Coolant passages are integrated into a complex stator cover casting to save weight and reduce powertrain width. The cooling system is designed to be aesthetically pleasing, easy to service, and rugged. Our goal was to provide desirable engine sounds, a pleasing exhaust tone, balanced with a visceral-sounding powertrain. Our water cooling system needed to enhance that balance. The engine oil is also water-cooled, which ensures that the engine oil performance and durability will be maintained in challenging conditions. The Revolution Max's two crankshaft connecting rod journals are offset by 30 degrees. The 30-degree offset creates a 90-degree firing order that produces a smooth power delivery, especially at high RPMs, while minimizing the amount and size of balancing weights required. The cylinders are offset slightly to accommodate the crankshaft design, with the rear cylinder positioned central to the rider, a choice made to enhance ergonomics. The rider may gain control and confidence because the power pulses of the 90-degree firing order can improve traction in some off-road riding situations. Harley-Davidson has a long experience in flat-track racing that helped inform the cadence of the Revolution Max engine power delivery strategy. The 90-degree firing order produces a pleasing exhaust beat. Moving to the piston crowns are machined for precise control of compression ratio. The 13-to-1 compression ratio improves engine torque at all speeds. This high compression ratio is made possible by advanced knock detection sensors. The engine will require premium-grade 91-octane fuel to make maximum power, but will run on lower-octane fuel and be protected from detonation by knock-sensing technology. The piston skirt has low-friction coating. Low-tension piston rings reduce friction, which improves performance and reduces heat. The top ring land is anodized to enhance durability. Full piston cooling is obtained through 2 jets per piston precisely targeted at the underside. These jets dissipate heat generated during combustion. 4 valve cylinder heads, 2 intake and 2 exhaust, permit the largest possible valve area. More area equates to better breathing. The customer realizes an optimal performance profile for adventure touring. Strong bottom end torque with a smooth transition to peak power because the flow of gases through the cylinder head ports and combustion chamber are optimized to match the desired performance requirements and engine displacement. The exhaust valves are sodium filled to better dissipate heat. Suspended oil passages within the heads are made possible by a complex casting technique and reduce weight because the head wall thickness is minimized. The dual overhead cam design facilitates higher RPM operation by reducing valve train inertia, which produces higher peak horsepower. The dual overhead cam design also permits independent variable valve timing on the intake and exhaust cam, optimized for the front and rear cylinder to broaden the power band. Specific cam profiles are selected to produce the most desirable performance characteristics and adjust on the fly depending on load and RPM. The drive side camshaft bearing journal is part of the drive sprocket, a design that makes it possible to remove the camshaft for service or a Screaming Eagle performance upgrade without disassembling the camshaft drive. The camshaft drive chain guides and sprockets have been optimized to reduce as much mass as possible. The chain tensioner is internally mounted and incorporates design features to minimize startup clatter. The Revolution Max 1250 engine model is equipped with computer-controlled variable valve timing on both intake and exhaust camshafts. Through computer control, variable valve timing advances or retards exhaust and intake camshaft timing independently and infinitely through a potential range of 40 degrees of crankshaft rotation. Variable valve timing broadens the overall power band and improves torque management and efficiency compared to the same engine with fixed valve timing. This allows the same engine to provide both low-end grunt for acceleration off the line as well as the thrill of high RPM horsepower. The cam torque actuated phaser is located between the cam drive sprocket and the camshaft and uses a solenoid plunger to control ported hydraulics to deliver continuous timing change. The Revolution Max 1250 engine features roller finger valve actuation with hydraulic lash adjusters. The design ensures that valves and valve actuators are in constant contact despite thermal expansion from engine heat changes. The hydraulic lash adjusters provide a quieter running valve train and make the valve train maintenance-free, saving the customer time and cost because there is no mechanical adjuster. The customer gains performance because this design maintains zero lash and consistent pressure on the valve stem, which facilitates more aggressive camshaft profiles. The Revolution Max 1250 engine is equipped with 2 spark plugs per cylinder. Dual spark plugs improve ignition of the fuel charge across this wide-bore cylinder. The Revolution Max 1250 engine is equipped with side strap spark plugs that are designed to better manage high temperatures in the combustion chamber than a standard spark plug. The rider gains overall performance when combustion is optimized. The engine oiling system is scaled to perform well in challenging conditions. The engine features a dry sump oiling system with the oil reservoir or sump incorporated into the crankcase casting separate from all rotating parts. This increases performance by reducing parasitic power loss that can occur when rotating parts must pass through an oil bath. Triple oil scavenge pumps evacuate excess oil from 3 engine cavities, crankshaft, stator, and clutch, that can accumulate in some riding conditions. For example, during sustained high-speed cornering, the rider gains optimal performance as parasitic power loss is reduced because internal engine components do not have to rotate through excess oil. The engine was tested running for extended periods of time at a 60-degree angle at 6,000 RPM. A windage tray improves oil recovery and prevents the clutch from aerating engine oil, which could degrade oil load capacity. The oil feed pump is fitted with a large capacity screen able to filter debris for the lifespan of the motorcycle. The Scavenge Oil Pump is designed to pull a vacuum in the crankcase, which can further reduce internal engine friction because a lighter piston ring pressure is required to minimize combustion blowby. Oil to the main bearings and connecting rod bearings is delivered through the center of the crankshaft, a design that enables a lower required oil pressure, 60 to 70 psi, to deliver oil at high RPM and avoids the parasitic losses associated with delivering a higher required pressure. Internal balancers cancel most engine vibration to enhance rider comfort and improve vehicle durability. The primary balancer is a spiral-shaped, chain-driven balancer located in the crankcase that manages primary vibration created by reciprocating masses. It also addresses the rolling couple, or side-to-side imbalance, caused by the offset cylinders. A secondary balancer, a small balancer located in the front cylinder head between camshafts, complements the primary balancer to further reduce vibration. The balancers are tuned to retain just enough vibration to make the motorcycle feel alive. The customer may gain motorcycle performance through weight reduction because engine components do not have to be designed to withstand stress from vibration. The clutch is mechanically actuated with a large diameter cable for smooth, consistent disengagement with minimal drag. The clutch assist function offers a lighter feel at the clutch lever while maintaining the ability to transmit full torque and power to the transmission. The clutch features 8 friction plates designed to provide consistent engagement and maximum torque throughout the life of the clutch. A clutch slipper function enables the rider to downshift without overspeeding the engine or slipping or hopping the rear wheel. The Revolution Max is a unitized powertrain, meaning that the engine and 6-speed transmission are housed in a common case. The 6-speed transmission shift system features roller bearings to support the shift drum and Teflon-coated shift shaft support bushings to minimize frictional losses and optimize shift quality. To maximize sound quality, the primary gear assembly was designed to achieve the optimal balance of sound quality and performance. A custom-designed scissor gear reduces both backlash and gear meshing noise. Compensation springs in the clutch primary gear smooth out torque pulses from the crankshaft before they reach the transmission, providing consistent torque delivery. Internal shift components are durable but also as light as possible to improve shift quality and acceleration by minimizing power losses during shift events. The Pan America models are equipped with a chain final drive, a significant departure from the belt drive used on all Harley-Davidson models for decades. A chain final drive meets the expectations of riders in the adventure touring segment who perceive a chain to be more reliable than a belt for off-road riding. The drive chain will require periodic lubrication and tension adjustment current Harley-Davidson motorcycle owners may not be familiar with. The exhaust system on the Pan America 1250 models is designed to produce a pleasing low-frequency tone and to meet global emissions, including Euro 5, and sound regulations without compromising durability or the performance experienced by the rider. The entire exhaust system is crafted from corrosion-resistant 304 series stainless steel. The strength of this material allows it to be thinner, which reduces weight. Stainless steel will not rust if the finish is damaged. The catalyst is located as close to the engine as possible to minimize its size and weight and to keep heat away from the rider. The system was designed with adequate room for the rider's boot when riding while standing. The Pan America 1250 and Pan America 1250 Special exhaust systems are designed to create as much clearance as possible under the motorcycle to limit potential impact damage during off-road riding and not to compromise lean angle during high-speed cornering. So the question I know that is on all of your minds, since we're here showing you all the technical details, what are the cold hard performance numbers? Our brand new RevMax engine boasts a 1250cc displacement engine, 150 horsepower, 94 foot-pounds of peak torque, peak RPM of 9,500, and a compression ratio of 13:1. The co-development of tires, suspension, and chassis results in a motorcycle that stays composed and confident to its performance limits. To discuss Pan America's dynamic chassis performance, I'd like to introduce Bjorn Christensen, Manager of Engineering Systems.